All right, everyone. As people start streaming in, I'll go ahead and start introductions. Hi, thank you all for coming today. My name is Fatima. I'm a fourth year graduate student in the science policy group at UCSF. We are a non-hierarchical group of students, postdocs, and faculty that are passionate about science policy and advocacy. If you're interested in joining and helping build more events like this, please go to our website at spg@ucsf.org or email us at spg@ucsf@gmail.com. You can also DM myself, Alina K, or our technical manager, Jack Stevenson, and we can add you to our Google group. We do want this to be an interactive experience, so there will be time for 1 to 2 questions at the end of the panel. Ideally, please type your question into the chat at the end or DM your question to Alina K. If you have any technical difficulties, please DM Jack. If you ask a question, we may spotlight your video to share your question in this space unless you indicate otherwise. Today, we have a really exciting set of panelists to help us understand what the future of AI entails and the ethical complications around it. First, I'd like to introduce my co-moderator, Helena. Please kick us off.
Thank you, Fatima, and hi, everyone. My name is Helena Mezgova. I'm on the leadership team here of the Science Policy Group and an analyst at the Institutional Review Board here at UCSF, alongside being a graduate student of bioethics. And we have a really exciting group of panelists. So just to get us started, to begin, we have Alex John London, is the Clara L. West Professor of Ethics and Philosophy and Director of the Center for Ethics and Policy at Carnegie Mellon University. His book, For the Common Good, Philosophical Foundations of Research Ethics, will be published by Oxford University Press later this year. He is an elected fellow of the Hastings Center, whose work focuses on ethical and policy issues surrounding the development and deployment of novel technologies in medicine, biotechnology, and artificial intelligence. Next, we have Christiane Lum. She is a senior staff machine learning researcher at Twitter. Previously, she was an assistant research professor in the Department of Computer and Information Science at the University of Pennsylvania and the lead statistician at the Human Rights Data Analysis Group. She is a founding member of the ACM Conference on Fairness, Accountability, and Transparency, and has served in various leadership roles since its inception, growing this community of scholars and practitioners who care about the responsible use of AI systems. Her research looks into the unfairness of predictive models with particular attention to those used in criminal justice settings. She received a PhD in statistics from Duke University. Next, we have Ramon Vilarino, and he is a first-year computer science PhD student at UC Berkeley. After participating in the development and deployment of machine learning models responsible for decisions impacting hundreds of millions of people in Brazil during his time at Experian and NuBank, he is broadly interested in the use of AI and computing technologies for resource allocation and the social interconnections that drive such use. And lastly, we have Ria Kalluri, and she is a PhD student at the Stanford AI Lab, researching ways to understand and change the values embedded in machine learning using mathematical, empirical, and social tools. She works on mathematical and empirical tools for making machine learning more understandable and critiquable, as she studies the way in which machine learning concentrates power while doing her small part in the collective work of creating radical AI and community care. Please join me in a virtual round of applause to thank our panelists for joining us today. And now I'll turn it over to Fatima to help define some terminology.
Thank you, Helena. I'll start with artificial intelligence. The concept of artificial intelligence, aka thinking machines, was the creation of Alan Turing in 1950, where he specified that in order for computers to function on par as a human being and be considered autonomous, they needed to pass the Turing test. Building off this theory, in 1956, John McCarthy coined the term artificial intelligence to represent machines that could think and act independently. In its essence, AI is the branch of computer science that aims to answer Turing's question to replicate or simulate human intelligence in machines. Furthermore, AI can be classified under 2 broad categories: narrow AI or artificial general intelligence. Artificial general intelligence is a theoretical form of AI and would be an autonomous machine with human level intelligence. Much of what is utilized today is considered narrow AI and operates within a limited context and serves to focus on one task, which is often powered in part by machine learning. Next, I will talk a little bit about machine learning. So while AI is the broad science of mimicking human abilities, machine learning is a specific subset of AI that trains the machine how to learn. It was born from pattern recognition and the theory that computers can learn without being programmed to perform specific tasks. Researchers interested in AI wanted to see if computers could learn from data. The iterative aspect of machine learning is important because as models are exposed to new data, they are able to independently adapt. They learn from previous computations to produce reliable, repeatable decisions and results. Next, I'll define black box algorithms. So black box models are created directly from data by an algorithm, meaning that humans, even those who design them, cannot understand how variables are being combined to make predictions. Even if one has a list of the input variables, black box predictive models can be such complicated functions of the variables that no human can understand how the variables are jointly related to each other to reach a final prediction. Finally, I will define the garbage in, garbage out problem. So if the data used to build AI is garbage, then irrespective of the power of the AI or the intelligence of the machine learning, the outputs will be wrong. This means that critical data points will also be wrong, leading to poor decision making. Garbage is a broad and expanding category in data science consisting of poorly labeled or inaccurate data, data that reflects underlying human prejudices, incomplete data, etc. And with that, we'll get started with our questions. Helena, I'll pass it over to you.
Perfect. Thanks so much, Fatima. So to begin on a broader note, what does the current application of artificial intelligence look like in your field? And what does the future of AI look like in the next 3 to 5 years? And Christian, we'll begin with you.
All right, so I should preface what I'm going to say by saying I'm going to be talking mostly, almost entirely in fact, about the work I've done on the use of algorithms in the criminal justice system over around the past 6 years. This is both because I've worked on that for a lot longer, and also I just started at Twitter, and the first rule of Twitter is you don't talk about Twitter until you've been there for at least 6 months, and I've only been there for 3. So if you ever have me back in 3 more months or later, I could maybe talk about that, but for now I need to talk about my old stuff if that's okay. And so in criminal justice, I think there are a variety of ways that AI is being used. And I'm using a really broad definition of AI to include things that are fairly simple machine learning methods, things that people who don't even think of as machine learning, like logistic regression, for example. So one of the areas where those sorts of models are used is in recidivism prediction. So essentially when someone is arrested, often models are built that will predict whether that person will be rearrested again based on things like criminal history, some simple demographics like age, and sometimes other things, details of what the arrest was about. There's sort of another category of algorithms that, or AI type of models that are used in this area, which are essentially predictive policing. So whereas these recidivism prediction algorithms take place after someone's been arrested, the predictive policing algorithms work on the front end of that and sort of help police I don't want to say better understand, but they make predictions about where crime will occur in the future or who will commit future crime so that police can allocate resources accordingly. And those use a variety of different methods. So typically more complicated than something like a logistic regression. But one of the selling points of many of these types of models is that the data that they ingest is fairly simple. So it'll be things like time and place of past police records, things like that. It won't take in, for example, things like race, demographics, etc. And so where is this going in the future? I think, so look, okay, so the recidivism prediction models are, like I said, fairly simple. They'll take in a few simple features about a person and make a prediction about their likelihood of rearrest. And then that will impact and influence and make recommendations about whether they should be released before their case is concluded. So these use fairly small data, both in terms of N, the number of observations they're built from, and also P, the number of features they're taking in. So where I think these sorts of things are going is they're going to probably expand a lot in both directions, both in the sort of number of observations and in the types of fields they're taking in. So all across the country, there are these government data fusion centers that are collating data about the same individual from different government sources. I think that's a really likely source of future data to be input into these things. So right now it's really only taking data from limited places, court systems, police departments, et cetera, things within the criminal justice system. I foresee they could potentially start including things from social services and other government agencies. Sarah Brain had a really interesting article a few years ago where she shadowed folks in the LAPD, and they were looking at the use of predictive policing models. And those models were beginning to ingest things like commercial data. Things like if you call into a pizza place and give your phone number and your credit card, and maybe it's the phone number of a friend's house and the address where the pizza should be delivered, they can sort of make these networks of who knows whom based on who's ordering pizza from whose house. And that was one of the things that she saw as being potentially used in those sorts of systems. So I think that sort of commercial data will be scraped up and used for these sorts of things. Also, government's intent to use social media as inputs to sort of algorithmic profiling in interest of public safety have already even been suggested by recent announcements by the Department of Homeland Security. I also foresee expanded use of surveillance technology to serve as inputs to these sorts of predictive models. So for example, automated toll passes, looking at automated license plate readers, et cetera, and GPS monitoring. And in fact, some researchers at Purdue University got a fairly large grant from the NIJ to fund work on incorporating GPS information from wearable devices, essentially electronic monitoring, into risk assessment, so recidivism predictions models. So that's sort of the data. I think it's going to get more and bigger, and I also think the models will get more complex, but I think I've probably surpassed my time on this question. So I guess I'll just say I think the models will get more complex to accommodate the increasing size and complexity of the data they'll be ingesting.
Wow, thank you so much. That was incredibly interesting. Wow, just a lot to digest in that, right? And Ramon, we'll go to you next on the same question. What does the current application of artificial intelligence look like in your field?
Yeah, so this is a complicated question, especially because of the time range. Since I'm a first-year PhD student, so I think I should be thinking about like my own contributions in the next 3 or 5 years for the field, and how I hope it changes like in sort of directions. As I said, I'm broadly interested in how using the use of these tools like turn into resource allocation. As Christian said, like how the using of we being able to make those predictions, however accurate or not they reflect in how we are allocating resources in society. I think this, so we have both these effects, like in trying to understand that, and how people, how the presence of this kind of system turns into like communities being more surveilled, or just like some communities receiving more resources from different kinds, because of like in the case of credit, for example. So those are questions that I think we should like understand better, and understand like how the introduction of these systems create like a market and an economy of their own. So this is one thing, but I also am really looking forward to see more things that can help us understanding more from the community's perspective. How can we include like their perceptions about their own needs, and how they are living their experiences, and what is this knowledge that you can only have like from this collective perspective. So I have no idea yet like how we are going to do that. Like I'm right now like trying to come up with like with all these problems and formulations to include these questions. But one interesting thing that came out recently was, for example, using machine learning to understand what values are implicit in a given public policy decision. So can we look at how the resources are allocated, can we understand better like what the decision makers were trying to optimize for, and like what are the priorities they come up with, and how well does those priorities really reflect the needs we have in reality, and the needs that the communities perceive they really have. And I think there is open space to both include more of these voices, and include more of like this more collective perspective, and actually hopefully like trying to hopefully moving away from only like this prediction based models that are really suited for surveillance. And I think there's something we'll go back to. So roughly that.
Perfect. Thank you so much. And Alex, will you tell us a little bit about your field and what you see the future of AI moving towards?
Yeah, so first, thanks for having me. So I'm not a technologist or a system developer. So my field is ethics. So I'll say something about what the future, I think, of AI and AI ethics is over the next 3 to 5 years. I'm struck by a set of recent systematic reviews about applications of AI in medicine that have found that few of the systems in the reviews are really ready for clinical development. And so my concern is that we're going to continue to see hype around AI in medicine that outstrips the actual capabilities of those systems until we see development timelines take place over a longer time period and start to resemble more of the medical model of intervention, development, and assessment. So having said that, and in particular involving more, not just in silico testing and not just testing on independent data sets, but also testing prospectively in real world populations to try to provide really credible evidence that the system can perform up to the standards that might be claimed for it by the developer or the person, the firm that's marketing it. So having said that, I'm hopeful, though, that we'll see more efforts to develop AI in medicine that follow much more of a medical model, and that some of our regulatory tools that we have to try to incentivize that will catch up because they're lagging behind. So we'll see less moving fast and breaking things and maybe more protracted testing and refinement in conjunction with clinicians and the other stakeholders who are going to be the end users of these systems.
Thank you, Alex. As a regulator, I completely agree with that point too. More regulation around this. And lastly, Ria, can you please let us know about some of the future of AI in your field and some of the things that you deal with?
Yeah, so I think it's, first of all, it's wonderful. Yeah, thank you so much for having us all here. So I think for some context, and I think like a bunch of us have just referenced this as we've talked, AI is like bigger than ever. Like the models themselves use more data. They do like more internal math. That means that they take up more like hardware. Like you need more like physical computers, right? Like you can't run AI models, the kinds of AI models that are considered, that we're referencing, right? That like companies use, that like orgs use, like those don't fit on a computer. At some point AI models did, they just don't anymore for most people. So that scale is huge. And these models at this point are often not domain specific. And that's also considered sort of new. The idea that you could have one model that could be the same model with just like a few tweaks that Google can use to help it like understand search queries and then figure out like what responses or what links to give you is like, could be the same model that some text editor uses to like finish your sentences or offer sentence predictions automatically. Could be the same model as like text analysis by police departments or governments to try to figure out like who's a threat, right? So this is huge. These models are physically giant and they span more domains than they ever have before. And this is like, yeah, this is pretty new. These are some, like Stanford's calling these foundation models. And that I think is one of the most important things to know about the state of AI and machine learning right now. And I think it brings up some really big concerns and some like immediate directions that people are starting to work on as a response to these. So given these models are so big, a lot of us can sort of naturally see that all of us are now being evaluated by these machine learning models. We're active participants, some of us willingly and some of us non-consentfully, right? Everyone in this, like on this Zoom call, I would venture to guess, is being evaluated by machine learning models. And I think that there's people that are really, there's already an increase in surveillance. Like we've seen that, that's one of the uses that's happened with these models. And that's scary for a lot of people. And I think that there's this increase in some people trying to say, well, like, how do we make these models better? How do we make them more participatory so consent exists? How do we regulate these models, put moratoriums on them for things like policing that are doing bad things right now? And how do we just analyze them and think about like how bad or good are these models now that they're proliferating so much? So I think that's sort of where things are and where things are heading. And it's sort of that diverging truth of optimistic and pessimistic things I predict.
Absolutely. Thank you so much for all your feedback. And Fatima, I'll pass it over to you for our next question.
Thank you, Helena. So AI, like many other discoveries, is a tool that can be widely applied. However, historically, AI has also caused damage to many communities, no matter the intent of the creator. What are some perspective and ethical challenges of the use of AI? Ramon, let's start with you.
Well, this is this is such a broad question in the sense that, but I think someone, a high school student, asked me the other day what I think was my biggest worry about AI systems. Like, oh, this is a, and after some reflection, I think what worries me the most about machine learning specifically, I guess, as a tool, is that people like it so much, and I think especially in industry, because you don't have to really understand what you're doing to be able to do something. So you're able to produce a tool that receives an input, it gives you a reasonable output that you can use to make decisions. And you can do this without completely understand your problem. Actually, that's the goal, that you have something that is useful for you to do something like that for, you know, in a problem that you can't really understand, like what the patterns that are there, and then you can just like look for them. And then you have this tool that you don't really understand how it works. Like on a problem, you don't really, you didn't have domain to begin with. So like this is very dangerous. So, and as we expand this community, like it's very easy to just to focus on like on the big companies and on the latest AI model or in the last like a curious background. But one goal of these companies and like with making this the use of AI more and more like easy to do with those libraries and everything, is that a separate consequence of that is that you have all different sort of players using these technologies. And for me, experiencing that from Brazil specifically was very worrisome, because we as a community were importing those ideas and using those tools, and people were using those tools to build businesses with all different kinds of expertise. And so the risks people are taking, or the risks that are out there on actual people's lives, are of all sorts, because we don't really know the use people are doing of those ideas, or we don't really know how consequential they are being or not. So, and I think a lot of the research, now going back to the other side, a lot of the research in machine learning, at least in computer science, I came to that impression after seeing this tweet from this prominent CS researcher saying that someone asked, like, what is the difference between how statisticians see machine learning and how CS people see machine learning? And one of the answers in this thread was like, people saying, oh, so statisticians are trying like to learn about something of the data, or making those trying to draw those conclusions. And the computer science community is more focused on building software. And I was like, wow, this is alarming, because if we focus too much on like having things that just work, or that just do something, and without like creating like extra cautions, extra barriers, to be sure that we are putting someone out there that like has like that has like content like that really tackles the problem the way we want to do, that produces knowledge that we can rely on, and not just like works for some like slap measure or something like this. People will keep using those things for more and more consequential stuff, and it has more and more consequences in people's real lives. And that's what worries me the most, like this balance in between being able to just build a tool that you don't understand to solve a problem that you don't understand as well. Like this is very challenging, and how widespread it is, and we have no idea. We have no idea like how it is like what is the distribution of care, you know, in the industry all over the world that people are taking or not when they are doing this kind of things.
Yeah, thank you, Ramon. Alex, could you expand on what you think are some perspective ethical challenges of the use of AI?
Sure. So, you know, a lot of my work is in medicine, so I'm going to stick to the medical context. I think there's an ambition, sort of following up on one of the things that Ramon said about the desire to sort of take the data and use AI to solve problems when you don't really understand the nature of the problem. So there's an ambition in medicine to sweep up the tremendous amounts of data that we generate in medicine in order to answer clinically meaningful questions. And one of the problems is that in medicine, the quality of the data that's available to AI systems is probably not what it needs to be to really support a lot of the tasks that we want AI systems to support in medicine. So a lot of the data that we collect in medicine isn't primarily for research purposes. In fact, a lot of the data that we collect in medicine isn't primarily for patient care purposes. A lot of the data that we collect in medicine is for billing purposes. So it may not be rich enough to support some of the tasks that we want. It may not be granular enough. It may not be enough of a meaningful time series. It may not have all the elements to the variables that we need to make clinical predictions. Also, the way that AI works, even with data that we would use, humans would use to make clinical decisions like images, it doesn't look at images the way that you and I do. So if sicker patients have their radiographs taken by portable machines, then a system that looks at those images and can tell the type, AI systems are very good at sort of finding correlations. And so finding the machine type, and if that correlates with the disease that you're looking for, then you can have something that learns from an arbitrary characteristic, right? And then its accuracy is going to really degrade out in the real world. So to fix these problems, it's not going to be fixing new algorithms so much as changing the way we collect data in medicine.
Thank you so much, Alex. That was a really interesting answer. Ria, would you like to add about what are some perspective ethical challenges in the use of AI?
Yeah, I think so. There is, I think, like a range of questions that people are increasingly asking about AI. And I think one way to articulate that range is, are you asking whether the data works for like one specific instance, right? For like me running a model on my friends, for Google running its model to like answer queries? Or are you asking about an entire domain? Are you saying like, what does machine learning do when you're trying to predict the like outcomes of radiology assessments like everywhere? Or are you asking, what about machine learning in general? Like, what are the inherent qualities of machine learning? And I think people are asking all of these questions, and there are ethical challenges at every single level. So there's the ethical challenges in that collecting data is hard, and there's and I think, you know, both of you have kind of gotten at this, that the data is bad. And even at the application level, it's unclear. Maybe we need to be regulating it a lot for several domains, right? Maybe we want to say that machine learning should never be used for policing. And there's folks like Deborah Raji and Timnit and Joy Bulmwini who translated work on the problems with data that led to problems in like image classification around gender, around race, and then used that work in the past year to do a ton, it's now 2 years, to do a ton of policy advocacy that was probably one of the biggest factors in the moratoriums on policing being allowed to use these technologies, right? That's huge. And that takes so much work beyond just like understanding the models all the way to doing a ton of labor to try to get policymakers to take that seriously. So those are big ethical challenges. And there's something that goes all the way on this side, which is we often say like oh, it's just a technology, like people use it differently, it's just because of the data. But there's a long history of many fields who have articulated why certain technologies just have inherent qualities, inherent politics. And like Langdon Winner wrote about this like forever ago. He was one of the first people who articulated in these words, which is like solar energy versus nuclear energy have just like fundamentally different qualities, and they do different things in the world. Solar energy is like, even if you can come up with applications where one is better or worse, solar energy is in a lot of ways just like more democratizing than these other types of energy. And so the same thing happens in machine learning, where you can actually ask, well, machine learning is inherently conservative, right? Like it only looks at data from the past, which is why these surveillance models can only see what has historically happened, and they will always replicate it. So if you're not someone who believes in like replicating these conservative patterns, then that matters in every AI model. And you can ask, like, is it inherently power centralizing? Is it inherently conservative? And do the fixes, do these little reforms to these models, do they feel powerful enough that they change what AI is? Or do they feel like they just reinforce that status quo with some ethics washing here and there?
That's wonderful, Ria. Wow, thank you so much for your feedback and your expertise on that. And continuing on, how are black box algorithms problematic? And is this all leading to the Terminator? And Ria, can we start with you again?
Yeah, sure. So I thought about that. Like, I haven't seen the movie The Terminator, so this is a problem. But, I think, so one thing I want to say about these models that I like, when these models, there's this narrative that they're black boxes, and some part of that is true, but some part of them is just that they're like a ball of yarn, right? Like there are these strings connecting these like input data to all of this output data, all of these predictions. And the difference, right, is that old school machine learning had just a few strings. So you could kind of say like, oh, this input is roughly leading to this. Now there's like sometimes a billion pieces of string connecting these inputs to these outputs. And so it's like more like this ball of string than it is this black box. And there's a bunch of consequences to that, right? So one is that there's so many strings, it is very black boxy, and the average person can't understand it. Even machine learning researchers, like they can mathematically say things about how many strings there are and what the strings tend to do, but very few researchers, there's just a few that try to say like, oh, actually, this model is using this input about text to reconstruct the gender of the speaker, or to understand that this image is actually of a car, right? That's maybe like a nicer example that we're okay with. So there's these strings mean that it's both obscure to the vast majority of the population, which is concerning because these things that used to be human decisions that maybe were also not interpretable, but at least not homogenizing to everyone and could be contested, right? You could say like, oh, this used the wrong feature. I challenge the use of this model. Now it's really, really hard for people to do that. And there's this shininess to AI where people sort of don't even feel like they need to defend it or can allow contesting. So yeah, there's that two-sided thing of the ball of string is really hard to interpret, and that sucks for a lot of people. And then there is like a few people that actually get to unravel the ball of string. And I think that makes these models a little more critiquable when we encourage more researchers to do that for the benefit of everyone.
Thank you, Ria. Very interesting. And Christian, can you please add your expertise on the subject? Oh, I think your mic is muted.
Yeah, there you go. On black boxes, right? So how are they problematic? I think one of the biggest ways in which sort of black box models are problematic is that it's hard for people to anticipate and understand what's going to happen. So if you have a model that's interpretable and fairly simple, a person can kind of gut check it. They can look at it and say like, okay, if I give it this input, and you can sort of do the computation yourself, maybe a little bit, and kind of figure out what the result is going to be. When you have these models, like Ria was saying, that are so, and I guess the other thing I would say is that in practice, I'm sort of stepping outside of the criminal justice domain right now, but in general, we're talking about these really complicated domains. It's not often just one model that we're talking about. It's a whole lot of models. It's one model, maybe like training embeddings that get input into some other model, they get put in some other model, and those all interact in this complicated way. And so it's often not just one model that's a black box, it's like a whole system that's a black box, which I think is a good sort of distinction to make, because when we start talking about solutions to understanding what's going on within that box, a lot of the work that I've seen recently sort of conceptualizes it as like a model. And in fact, there are so many moving pieces that could be developed separately, independently, sort of interact with one another, that a lot of the things that people talk about in that space, I think, don't really recognize that. And so let me look back at my notes. Yeah, so like I was saying, I think if you have simpler models that are more interpretable, humans can look at it, say, okay, I think this could go wrong. I think this could go wrong. They can have that sort of foresight to think through what could happen. I think it's also a lot easier when it's not the case that things are just so complex, you don't even know where to start. So you could start thinking about things like counterfactuals. Okay, what if this were the case? What if this were the case? Then what would that be to start reasoning about? Is the model performing in a way that I think is fair, justifiable, all of those sorts of things. And I think in the sort of stepping back into the criminal justice domain, when we're talking about decisions that are so incredibly consequential for the person about whom they're made, I think this becomes problematic when the inputs to those models end up being so high dimensional that a person can't actually defend or contest them. And this sort of ties into something Ria was just saying. So if we're going to be using data or inputs in this sort of legal context, I think it's someone's right to be able to contest those. But if you're talking about some million dimensional vector of inputs, the person can't possibly fact check all of those or argue them or have their attorney argue them. And so I think that's another issue that we encounter.
And Ramon, do you have anything to add in your expertise on the subject?
Just like to echo both what Ria and Christian just said, but adding just like another thing that is like, we usually are used to think about the systems like in making the right predictions or making the right call, and just true that a lot of times, and in some cases, most of the times, they don't. And the fact that they are hard to explain and interpret, I think it builds on a tradition that we have been into like as a society for a long time of just not challenging tools and taking like those measures for granted, like they were simple things, like from thermometers to deep neural networks. And that's just not good, like, because as we have been saying here, like we start from a place from a problem we don't really like deeply understand, and then those things are useful because of that, and then we get to this ball of yarn that mixes all those informations and do something that, and if we just lose track, and if people like as societies lose track of our own ability to challenge those decisions, to challenge those predictions, I can see this leading to a good place. I don't know about the Terminator, but it's definitely it's definitely not a good relationship to establish with the machines, to not hold them accountable in that way.
Thank you. Thanks so much to the panelists. And Fatima, I'll pass it over to you for our next question.
Thank you, Helena. So our next question is, can you expand on machine learning and the garbage in, garbage out problem that is recreating the problem of racism, sexism, and ableism in AI, given the biases in our input data? Alex, let's start with you.
Do I get to answer the opacity question?
Would you like to? Feel free. We were just trying to keep time, but go ahead.
Oh, no, that's fine. If you want to save time, I'm happy to move on. Sure. So I'm more of a contrarian on the other issue. So okay. So in the garbage in, garbage out, because models are learned from data, as you said, Fatima, in your introduction, there's a real sense in which the system you train can never be better than the data you use to train it. And in medicine, in particular, our data reflect the shortcomings of our health systems. So access to medical care is often skewed by demographics like socioeconomic status and race. And as a result, the data sets that we have in medicine are often biased in similar ways. So in dermatology, data sets of skin lesions often don't include significant representation of patients with the darkest skin tones. Genetic databases are predominantly white European. Historical data that we have about treatment outcomes reflect an interaction between the social determinants of health and the underlying biology of people and the care practices that we use in medicine. And in the United States, social determinants of health are very unevenly distributed, and there's a history of social exclusion of women and populations of color from medicine. And so as research, the medical data that we have are often highly confounded. And if we take past data at face value, then we can recapitulate unfair practices because we can give less aggressive care to patients of color because prior data says that worse health status is closer to the status quo for them than it would be if we had a more just distribution of healthcare or the social determinants of health.
Thank you so much, Alex. Towards the end, if we have extra time, we'll definitely come back to you for our last question. Sorry about that. Helena, oh, sorry, not Helena. Ria, could you add to that, our earlier question? Can you expand on the garbage in, garbage out problem?
Yeah, I think one thing I want to name for people is that I think we're referencing it right now, the garbage in, garbage out, as like a way to critique these models, right? As saying like, oh, since there's bad data in the world, we should be really thoughtful and cognizant of where these are applied, if they should be applied. The garbage in, garbage out like quote is also used by a lot of people who are working against the critique of AI systems. And in particular, this is like a lot of machine learning researchers, and there are wonderful machine learning researchers. I have lovely peers. And there are lots of folks who believe, like, as a machine learning researcher, all I do is work on the model. Like maybe the input data I use is just like toy data. It's like a bunch of numbers that I'm turning into like a categorization, like of which number. It's very simple. And so like, it's not my problem, right? Like if someone uses down the line with bad data in a hospital or for an application like surveillance, well, it's just garbage in, garbage out, right? And like, I think we need to I think it's useful for a lot of people to know that too, that that's like not true. And that just relying on garbage in, garbage out as a narrative lets a lot of people off the hook. And the reality is that AI models, the way you build them can result in centralizing or not centralizing power. And if you build them, has that consequence too, right? And so if you value models that machine learning researchers can understand, you might start making them mathematically simple, and that's cool. I love math. And you might not care about making them consentable. You might not notice that it was actually like a really cool problem to think about, well, what if everyone whose data is used in a machine learning model, by the architecture of the model itself, were allowed to revoke their data, like influence the decisions of the model, right? Like these are interesting problems that we let people off the hook for, right? And there's these questions when sometimes we can get swayed by the dominant language around, oh, models are biased, they have bad data, they need to be more fair, accountable, right? Like some of these are good words and there's some benefit to them, but there's also, it's worth noticing, like, well, as a person, do you value fairness or do you value justice? If you care about transparency, do you value just being able to see into the models, or do you believe in people's like consent and contestability? And so I think we like want to be really careful, and people on this call listening should feel really empowered to be like, okay, not just the word that people say is negative or positive about these, but what do I want to see in these models? That's beyond data. That's about their inherent architectures, their use in the world, and whether that like excites you or really concerns you. I think you should feel really empowered to think about that. Yeah, maybe I'll pause there and see if we can come back to it.
Thank you so much, Ria, for that wonderful answer. Christian, would you like to expand on the garbage in, garbage out problem?
So I think I can just give you an example, because this is sort of the example that first brought me to this space. And so this takes me back to predictive policing. Let's take a step back. It's 2015. And we hear about predictive policing, and there's this, actually it's 2016. And this paper is published that actually lays out the algorithm that a company is using to make predictions about the locations of future crime. And so a project that a colleague and I did was we actually took real police data from the city of Oakland, because the city of Oakland had allocated money in their budget for the future to purchase similar software. And so we took this policing data from the city of Oakland and we looked at where it would allocate police in the future. But before I'm going to tell you where it would allocate the police, let me tell you about this data. So when we looked at the raw data as it was. We looked at the data on where police knowledge of drug use was in Oakland. And it was essentially only in a few places. It was, I wish I had the map out. I wish I had slides, but I don't. But it was in a predominantly African-American or Black area, and it was a predominantly Hispanic area. That was really the only places where, if you were to make a heat map, so places that show up really bright, where there's a lot of observations, those are the only places that lit up. And this is despite the fact that if you look at public health surveys on who's using drugs, for example, it's pretty even across the board. There really aren't huge racial disparities in drug use patterns, at least according to this other view of you know, drug crimes that's coming from a different source. And so when we ran this data through the algorithm that was making the predictions, lo and behold, it reproduced the exact patterns we saw in the data. So it would essentially reallocate the police right back to the Black neighborhood and right back to the Hispanic neighborhood. And in fact, it would make the policing even more and more concentrated in those areas over time. So it creates this feedback loop, right? Where you go to those places, you could maybe find a little bit more crime because you're there looking, and then you feed that back into the algorithm and you start going back to those places again, et cetera, et cetera, et cetera, until you're so sure, the model's so sure, those are the only places it needs to be looking, it kind of collapses in on itself. And so I think that's kind of just a, I don't know, an illustrative example of what people mean when they start talking about the sort of, you know, structure of the data, or the patterns of structure that the machine learning model learns from the data being reproduced. And in this case, I think, you know, a sort of common phrase I've heard thrown around in this space, instead of garbage in, garbage out, is more like bias in, bias out. So if you have data that encodes patterns of unfairness or injustice or any sort of undesirable historical traits or patterns in the world, models will learn those things and reproduce them without, you know, special care to make sure that that doesn't happen, and, you know, acknowledgement of those issues.
Thank you, Christian, for your expertise on the topic. Since Ramon ceded time on this question, Alex, can we come back to you on question 3? How are black box algorithms problematic, and is this all leading to the Terminator?
It's okay if you want to skip me on that, really.
Well, we still have a little bit of extra time since
Okay.
time. Yeah.
Okay, then, all right. So I guess what I would say there is I'm a little bit of a contrarian on the issue of explainability, interpretability, transparency. Only not because I don't think it's a good idea or that it's important. I think it's great. I think if you can have transparent models, that's the best situation. But my worry is that transparency is being asked to do more work than it really can do. So in medicine, being able to explain the way a model works isn't a guarantee that it's going to be actually able to do anything good for anybody. We can explain why we think all of the drugs that we put into drug development are supposed to produce good outcomes for patients, or why we think they're likely to produce good outcomes for patients. But 9 out of 10 drugs that go into drug development aren't approved for any indication ever. So I think your explanation of what's supposed to happen, given your model, that doesn't necessarily link up to what's going to actually happen in the world. So I would rather see clearer guidance about the use case for particular systems, the very specific tasks that it can perform, what the evidence is that it can perform that task up to the level that that is claimed for it, what the conditions are under which that model will have that performance level, what the conditions are under which that would degenerate. Because we could answer those questions for aspirin for 100 years and use it to cure people's pain before we could explain how aspirin worked. And in that sense, medicine has been using black boxes to help people for a long time.
Thank you, Alex. I will pass over to Helena really quickly for the next question. I apologize, Ria, I know you want to go, but we're really running tight on time now.
Oh, this is a good debate. Okay, at the end, we'll add it all in the last 5 minutes, and then hopefully it will all work. And now we're just going to switch gears a little bit into the next question, which is, how does artificial intelligence affect human behavior and interaction? An example could be social media. And Ramon, we'll start with you on this one.
always forgetting to unmute myself. So I'm actually gonna go a little bit back to answer this one and not change gears so much because I happen to live in West Oakland right now. It's one of the black regions of Oakland here. So you can imagine how if that system was implemented and the increasing presence of police, increasing my chances of being harassed while I'm going back home from the lab at night, how this would change my behavior, how this would impact me every day. So these are like very real consequences. As for Brazil, thinking about like how those are using, and I'm framing this in this resource allocation frame because I think that's where like a lot of the power shifting happens. Like we have it's very well described how redlining was important to keep like the racial gap and to keep the racial disparities in the US. This is not you don't have a complete history or like as popular history of that in Brazil, but now we are using those algorithms that people are not taking all of those cards, all those evaluations and allocating credit there, and they are there, and the evidence is they are probably reinforcing the same kinds of racial disparities nowadays. But now we don't have like we don't have like the proper tools to reveal those kinds of how these resources are being allocated, not the habit to challenge those predictions. But on top of all that, people get to be how can I say this? People get to not be taken accountable for how these predictions are being used. So one thing that I also think is an important case of changing or affecting human interaction is when a judge uses a recidivism tool to give a sentence to someone, and then it feels excused, like to export its responsibility for the algorithmic output. And I'm sure this changes how this person how that person feels responsible for the decision they are making on another human being life. And those are the ones that worries me the most.
Thank you. And continuing on with this question, Ria, how does AI affect human behavior and interaction?
Yeah. Oh man, how many ways? I think I said like everyone on this call is evaluated and has their like actions influenced by AI very frequently. I think there's like the really explicit examples that we talk about where people making big decisions about people, right? Deciding whether or not to give them a loan, to allow them like to set bail, to even like college admissions. There's all these things that are very specific and explicit that are pretty scary, right? That like these models would get to do that, and we don't know that much about how these models work. It's like arguable whether or not they're better than the people who have done it, but if they replicate the biases, right, like you're influenced by these. Then there's, I think, a lot of the really invisible stuff, which is partially like, there's a few things here, right? So one thing is that machine learning, like when it's researched, when it's like articulated, it's often articulated as if it's like, again, like it's not operating on people, and it doesn't really matter if it is, right? It's built to operate on anything, like shapes, images, whatever. But lots of folks, Abeba Barani is a good friend, and they've talked about this, other people have talked about this, that like when you evaluate and predict things about people, you change what they do, right? Like you don't just evaluate what they're about to do, you predict, you give them this information, and then that influences what they're about to do. So if you predict that they're going to, they like have a lower income based on their Facebook profile and give them certain kinds of ads for certain kinds of houses, now they are going to like, they're working in the context of that prediction, and then they're going to like take this housing that was maybe designed for a certain kind of person, maybe it's exploitative, who knows, right? So there's all these like implicit things. And another big thing that happens is that the people who maybe would most be harmed by machine learning often have the least ability to opt out. because if you are harmed by machine learning, usually that means that you don't have a ton of resources, right? You like can't avoid the machine learning models because you can't avoid the social services assessments or the government surveillance, right? Like you don't have the resources to put yourself in a space where people are like, oh, you have resources, you're wealthy, like we're not going to bother you, right? So you might be someone who's harmed by machine learning. And often those people then have to rely on these systems that if they opt out, they're given less resources, right? So if you're evaluated by, if you're evaluated to see whether or not you qualify for food stamps and you don't want to be evaluated by the systems, then you're not as likely to get food stamps. So it's sort of compulsory participation in these systems. And again, like, where's consent? Very unclear. Like the amount of papers that are machine learning papers that reference consent is like way low, right? That's not a thing we talk about. So I think all of these ways are ways that we're influenced by these models. And again, I think there's a lot, we're also just influenced by the narrative around them. We're influenced to believe that this is just the way things are, that the same way, right? It's kind of like this argument that like, oh, AI just naturally will exist and should exist and it's impossible to challenge, the same way surveillance is like, has always existed and you can't challenge it, or the prison industrial complex or policing, right? There's these narratives that machine learning is there forever, and these narratives influence our choices. They make us think that we can't opt out, we can't challenge, we can't advocate against, we can't create alternatives. And I will get to moments that I think you can challenge these things because I've said a lot of the harms, but I think all of these are ways that we get really influenced by these models.
Thank you, Ria. Yeah, exactly. Some of the concerns that you brought up, informed consent alongside all the other issues, those are ones that keep me up at night too. And to add to this discussion, Alex, can you please let us know, how does AI affect human behavior and interaction? How would you answer this question?
I would say that how AI affects human behavior is going to depend on how those systems are designed. And I think we have to resist thinking about AI as though it's general AI, as though it's an agent out there in the world doing things on its own. And instead we have to ask, what design choices have humans made that influence the way that AI systems are mediating human relationships? Are the humans who design these systems designing them for their profit? Are they designing them to produce pro-social outcomes? Are they designing them to produce, to distribute penalties or to provide social support for people? Because each of those things is a choice. And the only way that we can hold people accountable, some of the most powerful and influential people in the world accountable, is by putting them back into the picture and making clear that their design choices are the ultimate thing that we're evaluating here. Because AI doesn't grow out of the ground. Someone has to make it. Someone has to implement it.
Well said. Thank you so much to the answers amongst the panelists. And Fatima, I'll pass it over to you for our next question.
Thank you, Helena. Our next question is, can we make AI good or equitable or not cause harm? If so, how? We'll start with you, Ria.
I think a lot about this question. I think I believe that like the critical work is crucial and is like valuable and beautiful. And I think I want to ask this question of, well, there are technology, right? Like books are a technology, and books were historically in this ivory tower in which like only certain people got to write books, and only certain people had access to creating them, to disseminating them, to controlling the knowledge that was proliferated in the world. And books have become this like deeply democratizing tool. Like they've completely shifted over time to be this like really grassroots political education from people to each other. And I'm curious, right? One question I want to ask myself is like, are there any ways that you can treat machine learning models like that as this thing that, despite all the ways that they're used by people who, have profits, have power, big companies, big governments, are there ways that you can sort of nuance that beauty and try to find it, try to see if it's there? And there are, right? Like there are ways that people have used machine learning models to find sites, right? To like find places when you look at continents, to find places that are going through like natural disasters, that have like a lot of casualties, like all of these sorts of things. You can create models, you can use models to help create like physical prosthetics that are as active as competent as a human being, like, right? So for those folks who are disabled, we can use these systems, if we so choose, to like get some of these capabilities that we would like to have that maybe some of our peers do sometimes. And there's just like a lot of capacity to create like art and beautiful things. Like you can use machine learning models super easily to transform any image into like a painted version of that image, to take like images of your friends and create this like little tiny model on your own laptop that is like this beautiful illustration of these images, right? And there's a lot of people doing that, using machine learning in these beautiful aesthetic ways. And it's really, yeah, it's hard. Like I don't want to over advocate for these like beautiful little things, because big companies can then use those to say like, oh, see, machine learning can be good. Like we don't need to challenge our use too much. Or researchers can say like, look, like some people are doing good stuff. And so it's this like really hard balance of saying, are there models that do this beautiful thing? Can me and my grassroots communities like do this stuff while also not allowing it to, still maintaining our like deep critiques of the systems? And again, I think that requires asking yourself, what do you value? Do you value abolition? Do you value art and aesthetics in the world, and trying to create models that reflect your own values?
Thank you, Ria. Christiane, do you think, can we make AI good or equitable or not cause harm?
I mean, I think it depends on what you're using it for, essentially. And I don't want to repeat too much of what Ria said, because I think there are some overlaps there. I think, you can define what's good, but you have to recognize that that is your description or your definition of what is good. That's sort of your definition of the outcome you're trying to achieve. So can AI help us to achieve certain outcomes? Yes, I think sometimes it can help us to achieve certain outcomes. I think the question is like, are those outcomes leading us towards more justice? Are they leading us to more equity? And who's defining what those outcomes are? Who's defining what, the world that we want to live in? And I know that sounds like super kind of like, I don't know, hippy dippy, like there's no solid answers, but when we start talking about these things, there really aren't. You can't just be like, okay, there's this one objective goal that everyone's going to agree is the perfect good, and we will use AI to get there. No, I don't think that's going to be true. So how can you kind of like mitigate some of the harms or some of the disagreements about how we could get there? I think depending on what you're doing, depending on what your goal is, I think getting and this is fairly trite at this point, by the way, but getting a diverse set of perspectives going into it, into defining the problem, defining the goal you're trying to achieve, and also defining like what could go wrong. I think, in the areas I've worked in the past, particularly in criminal justice, there's now this move to get impacted communities involved. I haven't really seen it done well, to the point where I feel like they're actually heard in terms of how they want the different models to be used and what sort of impacts they want those to actually have. And also recognizing that no group of people, we talk about impacted communities as though it's a monolith. It's not. People even within the same demographic group, people even within sort of the same position in society, people who you would probably think are fairly similar based on any sort of measurables you might have about them, do have differences of opinion when it comes to the world that they want to live in, and what fairness looks like, and what justice looks like, and all these sorts of things, right? And so recognizing how you can balance that, also recognizing that the people who are impacted by the sorts of models are often going to have the best sorts of intuition about what can go wrong. So asking them, talking to them, like, hey, like asking them to contextualize the data, like, what does this actually mean? Right? And like, how do we want to use this? How could this actually hurt you or someone like you, or how could this hurt your community? I think those are the sorts of things that can help us mitigate some of the problems that we might see going. The other thing I think that is important is ongoing monitoring. I think oftentimes we think there's this sort of one thing, there's this like validation step, model is validated, now we're done. We know it's not going to at least have these particular impacts that we've anticipated and checked that it might have. But, you know, all of this is a moving target. Society changes, people change. The model I was talking about earlier, the sort of recidivism prediction, the policing sorts of models. And there's a real human component of that too. It's how people are using them. It's how they're influencing how judges make decisions. It's how it's influencing how police make decisions. And so it's not just a matter of monitoring the model by itself. It's this bigger question of monitoring the impact of that on society and on people. And that's actually a lot harder because I mean, it's hard to get that data is essentially what I would say along those lines. It's hard, and for good reasons. You want to keep a lot of that data private. The last thing that I think we should really be thinking about to make as a sort of, I don't know, safeguard or something is thinking through what the consequences are of opting out. So one of the things I forgot to mention when I was talking about where I think in the sort of criminal justice space a lot of this stuff is going is you can look at papers and they're somewhat speculative, but not that much, talking about using things like brain scans in these sorts of things or other biometric measurements to predict future recidivism. You know, a brain scan is, I mean, I don't think it's painful, but it's fairly invasive to have someone have like, you know, brain imagery of you. Like, what are the consequences of opting out of that? Should you be able to opt out of those sorts of things? I mean, yes, of course, right? But does opting out actually say cost you the chance of being evaluated by a model, which then may give you the opportunity to be released, right? Like, I think so thinking through how can people opt out without these huge consequences, diverse perspectives and ongoing monitoring, not just of a model or of the AI itself, but of its impacts on the system as a whole.
Thank you, Christian, for your expertise on this subject. Ramon, can you expand on whether or not we can make AI good or equitable?
Yeah, I think I want to build on something that Alex said in the last question when he said like AI does not come out of the ground. So to me, this question whether AI can be good or not is very much the question of like who gets to build AI. Because as Ria said about like how people can build their models in their laptops and make like this pretty image for their friends and put these beautiful things into the world. But that's not true about what we call the state of the art, or about like whatever technologies winning best papers awards and NeurIPS. So what does that mean for the future of AI? Like, because this is something that worries me a lot, because like the future developments that, you know, the future generations will be able to make, they will be based on the decisions we are making now. Like we'll probably won't solve the AI problem, whatever that means now. So, and we as a community, if we keep going this direction, that whatever AI means, it keeps meaning just needing more and more resources and more in a more centralized way, then that means that the people who get to build AI are the ones who control those resources. And even though AI as a concept, as a body of knowledge, as a set of ideas is very political, and and there's like all the ways we can see that all the ideas we just like inherit from the army, risk minimization and all those detection stuff, and all this bias towards making prediction and surveillance, like how it's very well suited for it are evidence of this. But as a body of knowledge, is not only where the politics happen. You know, like AI is very political, but at the end of the day, it's about like who is controlling the resources that AI is allocating out as well, and what we'll be able to do, and what are the resources we need to build AI, and who gets to put their values in there. And last week, we had the EMO conference, Equity, Access, Algorithms, Mechanism, Optimization. And in one of the panels, someone said about this, a constant conflict they saw between researchers wanting to help with school allocation problems and the parents and the students' real problems. So a lot of researchers were interested about like in solving the problem of school choice and people being able to choose their schools or whatever. But when you actually ask the parents, like they were not worried about like whether they get to choose or not, only if they like get to a good school or a problem like this. So my question is like, if people were to choose the problem they wanted to solve first, would we be building the same things? Or would we be building different things? And I think whether AI will or not be able to be like used for good will depend in basically, and who gets to say what we are using it for and like, and what we are building it for. So yeah.
Thank you, Ramon. Alex, would you like to expand on this question?
I think I can be brief. I think I'm not as pessimistic as Christian seems to be. I think a lot of my colleagues are out there working to use data and algorithms and AI for good social purposes. They tend not to be easily commodifiable things that can be sold and generate shareholder value for a lot of people. So I think if we want to use AI for good, we have to incentivize that. I think the powerful companies that are using AI on the largest scale right now basically operate with impunity, and we can change the incentives that they have, and we can change the performance of the AI systems that they operate with regulation and the law. And then I think that the way to get more AI being employed for good social purposes is to allocate funding that's specifically for encouraging people to put the teams together to get the data and develop the algorithms for specific, good social purposes. I don't think it's a big philosophical question like what's the good and how do we use AI to achieve the good for everybody. There's lots of little ways you can use data science to improve the lives of people, and we just have to incentivize that.
Thank you so much, Alex. I definitely like that aspect of using policy to better this particular field. So people have definitely spoken, and we want to come back to you, Ria, and let you respond to Alex's earlier comment on black box algorithms, and then let you both go back and forth a little bit on the issue. Ria, please take it away.
Yeah, well, maybe, is this like the open question period, or do we have a few more questions to cover?
We're gonna just let it be an open question period now. We've cut our last question. Yeah.
Yeah, maybe we'll get back to everyone. It sounds like everyone has, yeah. So a few things I want to say. One thing is this question of, is AI good? Can AI be good? I think a thing that I've said a lot in the past and want to say just like really clearly here is this question of like, is like what is good, who gets to choose what good means and who good is for. And like a thing that I wrote about, I remember, was just focusing on the fact that we ask a lot, is AI good? And more recently, is AI fair? And I think a much more powerful, timely question is, how does AI shift power? And the question is, do mainstream models shift power to most people, or do they shift power and resources to large companies, to large governments that already have resources? Like the answer is the latter, right? Big governments and big companies. And the things that I mentioned as feeling really beautiful, right? The things that I mentioned feeling like, oh, can we do something that's kind of book-like, right? The thing behind that is what I'm saying is like, can we build things that feel like they shift power to each other, to our grassroots orgs, to our communities at the margins? And there are people who are using machine learning to like preserve oral histories of communities around languages that are no longer common, right? Or yeah, I just want to name some of those. That's one way to divide up this question of like what gets to count as something we want to pursue versus something we don't. And then the another thing that I'll say that is more of a response to kind of this broader question about like, what about this black box stuff is not like a disagreement with anyone in particular. I think it's just to say explicitly, and I'm going to keep coming back to this point, like, what do you want out of this models? What are your values? One answer to this question is like, actually, like a lot of people have been convinced that like transparency is inherently a good thing. But I think Alex started to kind of mention this, which is that actually there's like papers that show if people are given a model that is supposedly transparent and you get to see a little more into it, they're actually more likely to be convinced of the wrong thing, right? If the model outputs a lie, but you're given something about the insides, you're more likely to say, oh, yeah, the model worked correctly. that's really concerning, right? And another thing that happens with transparency is, and I mentioned this in passing, like ethics washing. These big places, these companies, these governments get to say, oh, like we've had these models, now everyone's concerned. We'll add a little debiasing. We'll add a little bit of a fairness metric in there. We'll add a little bit of transparency. And it gets to be ethics washing, and then they get a pass for continuing to use these models because people don't quite know how to disagree or contest when transparency and fairness is so hard to like understand, right? It's kind of this fresh-ish field. So I want to just challenge the ways we like buy into transparency or even fairness as being the right thing. And there's like we mentioned this. There's this thing about how just one more instance of that place where we can get tricked into a thing that we don't really value is like me and some of my peers wrote this paper that just read like 100 machine learning papers that are really popular. And there's a ton of papers that say the word efficiency, right? And that feels really exciting. Like, oh, maybe these researchers care more and more about building models that don't require a ton of data. That feels nice. I don't have a ton of data about myself, but if you actually read those papers, the portion of them that say they use fewer resources is tiny. And in fact, a lot of models that claim to be more efficient, actually what they say is we're more efficient in the sense that we're so small that we can be run on many GPUs, like many, not just one computer, but 1,000 computers at the same time. And that's efficient because it takes less time. That's wild, right? And so I think we just have to keep being careful about, we don't want this like value efficiency that's been sold to us, or this value of fairness or transparency. We want models that shift power to people that need it, including communities at the margins. That's my thing that I just wanted to make sure we got to say.
Thank you, Ria. Christian, Ramon, Alex, feel free to unmute yourselves to respond or give your thoughts.
I'll just say out loud what I was saying in the chat over here. I mean, I think my response about whether AI can be used for good, I definitely didn't mean it to be entirely pessimistic. Like, sure, of course, there are applications that are going to be good, right? I think I was just, I guess, sort of to be succinct, just trying to say, sure, you have to define what good is. Not everyone will necessarily agree with that. There are probably some applications that most people will agree with, but yeah, sure, it can do some good.
I think I could say I was the pessimist one. I never said it could. I just said that I don't know. And I think the factors I put in actually make me believe it won't really, but I hope it does. So it's just desperate. So.
Perfect. Thank you, everyone. And so we're slowly beginning to wind down, and we just wanted to leave some room for some final thoughts. To any of the speakers, Alex, starting with you, any final last thoughts on artificial intelligence broadly, or wanting to expand on any of the questions or conversations we had today?
So you want final thoughts? Is that?
Yeah.
Yeah, I guess I would just like to reiterate that, there's that saying, like, the devil's greatest trick was making people think that he doesn't exist. And I think that the greatest trick of some of the most powerful companies who are using AI in ways that are questionable, the greatest trick they ever performed was making people think about the AI and not about the role that they play in the way that systems are designed and used. And so the thing I would re-emphasize is AI right now is not general intelligence, it's a tool. So all these questions about what can AI do are really not well formed. We can ask, what can very specific applications of AI do given the data that we have and the kind of way that we formulate this problem? And if we think at that level of granularity, then it's easier to put the people back into the equation. What kind of what questions are people using AI to try to answer? What problems are they using it to try to solve? And are those good design decisions, or those poor design decisions? Are they pro-social or not? And so I think our first step to sort of bringing back accountability for these large systems is bringing the people back into them. And then the other point I would just make in terms of these, medicine is an area where it's just a lot of little, very specific applications, right? Let's try to read, diagnose COVID from radiographs or diagnose skin lesions. That's fertile ground for really impressive development, as long as we can move past in silico development, where you get a paper out on a sort of 1-year conference cycle, and move to the longer period of really building out these systems, testing them in advance, testing them prospectively in the real world, and sort of in that sense, moving the development process less from a kind of computer science model. I don't mean that with disrespect, but more to like a medical model, where you've got a range of questions about safety, efficacy, indication, the instructions that people need in order to use a system, and you've done a clinical trial basically to show that, yeah, it can do what you claim it can do. That's medicine in that sense is a simpler world than the world of Facebook and Twitter and large scale algorithms like Amazon uses and so on.
Absolutely, thank you. And thank you for pointing out the human-centered approach to artificial intelligence as well. And moving on, Christian, any final thoughts today?
The questions were there were a lot of comments made that I feel like most of it's been said. I think if I could close with, I guess one thing, and this is totally far afield, so I apologize, and it's not something we necessarily said tonight, but this is my personal rant right now, is I feel like a lot of the issues with AI have been focused around bias. And that's essentially this word that is used to mean like literally anything you don't like about the model. I would be totally happy if I never heard the word bias again. We could just start talking about the impact models are having on people and figuring out if we like those and if there are disparities in those.
Thank you. And Ramon, any final thoughts?
I think I'd just like say goodbye and say that it's just like great to be here. It's a strange time to be here, I guess. Like I'm going through the major change in my life so far, like changing countries, changing language. Like I'm learning to live my whole life in a different language right now, in a different place, and also revisiting all those ideas. So I think I don't know a lot of things, and and those first weeks of grad school have been like just like revolving all those ideas and all those hopes as well. And I think sort of my participation here was reflected that all of the questions we had here, I'm struggling with them, and I think the community is struggling with them. But I'm also very hopeful because what I think what brought me here to this community from the community in science I was before, which was more close to theoretical physics, is precisely that these conversations are happening, and that whether it be because like the path between like the abstract research idea and the impact on people's life is very, very short in ML and AI. Makes us having this conversation, but the fact that we are having them, that we are like talking about this and like this discussion happening out there, I think this is also happening in a different way that we have seen with the other areas of science that also concentrated power, that also changed the way we live our lives, that also changed the way we interact and our reactions. So I think that the only like the existence of this panel and a lot of panels like this that have been going on are reason enough for us to be hopeful and not to give up engaging with this community and how we want to shape how AI is going to be built, or what AI is going to mean in the next 10, 20, 50, 100 years, whatever. Yeah. Thank you.
Thank you, Ramon. Thank you. And Ria, will you close this out? Any final thoughts here?
Yeah. I mean, I'm really grateful to be with all of these panelists and you all. I think there's like a few things around here, right? So I think one thing is notice, right? Just like keep in your mind that the people that are using the most AI right now and are using the AI that works the best right now are those that have the most profits and power. That's true. And so I think like every time we think about these technological questions, we have to remember that. And I think a thing that goes with that is even applications that you think are sort of more okay, like they're not devoid of those same problems. So even medical contexts where maybe we think like there's like more fruitful specific use cases, and I totally value that. It's also true that there's like historical like race problems with how data is collected, like, right, like the maternal outcomes for Black women tend to be terrible. So if we use that data, then like we're going to run into problems of how we classify things in the future. And that's that kind of lens of like, oh, is this conservatism, right? Like, are we using data from the past in a way we're going to replicate? Or are we really actively trying to create things that are participatory, consentful, future oriented? So yeah, I think I want to say that like every level we want to ask those questions. And I want to say, that like AI should feel like we should feel empowered to not take AI as like a thing for granted. And this is the thing I said about how like AI is just, it's so closely linked with surveillance. And so I really encourage people to read about surveillance, the history of surveillance, and like the abolitionist critiques and all the people working against surveillance and the systems it's in, because I think you can learn a lot about feeling about the methods and goals of challenging these systems and how that is a very valid thing to want or to be concerned about or to consider. And on the last side, this little thing is, I also think you should feel empowered to like try out a more like beautiful relationship with AI, like in your like little space. There's these like little projects like Dear Data, where you just like look at your own personal data and collect it in a way that feels artistic and beautiful. And you can just do that for yourself, for your friends, play with it and get like a more intimate connection of like, do these things feel empowering for you? And what values can you embody in these technologies? And that's a really vulnerable ask, which is why many of us in this call who are saying something positive feel like it's really scary to say something positive. Like we want to be like tiny positive thing, but get back to the harms, because there are so many harms and people take these tiny good things out of context, right? So I think it's like both and. You can see these beautiful critiques of the huge models. You can see these beautiful, strong critiques of the everyday models, and you can try to develop a more intimate relationship with shaping these models in terms of your values. And I hope people can just like feel empowered to do all of those things.
Great. Thank you so much, Ria. I wish we had like 10 more hours so we could talk to you all about everything and like be able to expand on everything. Unfortunately, we are at the end. Please join me in a virtual round of applause for our panelists. Thank you so much for joining us today. If you like this event or if you hated this event and have ideas about what we should do instead, please join us by going to our website, spg@ucsf.org, or emailing us at spg@ucsf@gmail.com. We'll stick around for a few minutes to answer any questions about the Science Policy Group. Thank you again to our fantastic panelists and have a great evening.